Welcome, and thank you for being here tonight. I'm Lisa Gromlich. I am Dean of the College of the Environment, and I'm very excited to be here as we celebrate 25 years of the Climate Impacts Group and recognize progress towards climate resilience across the Northwest. I'd like to start by acknowledging the Coast Salish peoples of this land, the land which touches the shared waters of all the tribes and bands within the Suquamish, Tulalip, and Muckleshoot nations. When the Climate Impacts Group was founded in 1995, there were no groups that we know of like it across the country, around the world. And in 25 years, their scientific body of work has established how climate shapes life across the Pacific Northwest, and how climate change stands to impact a wide range of sectors and communities. Through collaborations with practitioners to develop data, tools, and guidance, and through trainings for scientists, practitioners, and community members, the Climate Impacts Group has helped establish our region as one of the front runners in preparing for climate change. The group's work of co-creating actionable climate impact science at the local level with people across the region has become widely recognized as critical for our efforts to prepare for the effects of a changing climate. They have become a model for working across disciplines and boundaries and to co-create science that is useful and used. Let me pause here and repeat that phrase. Co-create science that is useful and used. I heard this phrase from Amy Snover, maybe a decade ago, and it stopped me in my tracks. It struck me as the key. The science is used because it is co-created. It is designed in collaboration with users based on a process of dialogue and coming to mutual understanding. It is a process that requires both great scientific prowess and absolute humility. And it's the CIG legacy, and it's the CIG signature. And thank you, Amy, for your vision and for your leadership. So this year has brought many challenges and events that have been discouraging, disappointing, and even heartbreaking. And we want to take this time at the end of a very long year and on the cusp of a new one to celebrate and recognize the wins in our work of building resilience to climate change. Tonight, we will be learning from two distinct panels. In the first half of the evening, we will hear from experts across the state of Washington about efforts to prepare for rising sea levels. In the second half, we'll turn our focus eastward on efforts to conserve wild areas and to ensure species such as grizzlies, lynx, and wolverines can thrive in a changing climate. We will hear from experts at the federal, state, local, and tribal levels, as well as a few CIG scientists. With that, I'll turn it over to Dr. Amy Snover, Director of the Climate Impacts Group and the moderator for the evening.
Thank you, Lisa, for your kind words about our work and for helping us kick off our 25th anniversary celebration. I'm Amy Snover, Director of the Climate Impacts Group. I've been with the Climate Impacts Group for about 21 years now. So I have seen firsthand how far this region has come. And I'm really excited to share these stories of progress towards climate resilience with you tonight. I have a couple quick housekeeping items before we begin. If you notice any technical issues during the evening, please let us know by typing in the chat box or emailing earthlab@uw.edu. If you type it in the chat box, your message will just come to panelists and hosts only. And if you have any questions about the work of the Climate Impacts Group, please take a look at our website, cig.uw.edu, or send us an email. Also, as you may know, the Climate Impacts Group is a member organization of EarthLab at the University of Washington. So EarthLab bolsters our work by providing support for events like these, providing financial management and strategic advice. We are very grateful for their partnership. I'd like to begin this evening by acknowledging that climate change can be overwhelming and anxiety-inducing. It's a terrifying emergency unfolding in front of our eyes with too little being done to stop or address it. In fact, the urgency to stop greenhouse gas emissions and prepare for the impacts of climate change have never been greater. But this evening, I want to let you in on what I call the happy secret of climate change. The happy secret is that there is more being done to prepare our region for the changes that are coming than most people realize. Tonight, we're going to take a look at some of the good work being done to prepare Northwest coasts and wildlife for the changes now underway. The purpose of this evening is to provide hope, to show what can be done when we connect science, community needs, and Northwest ingenuity and creativity. To celebrate the scientists, public servants, and community members who are doing the hard work, the creative work, the generative work, the essential work of preparing for climate change. And to express our gratitude for those of you who make our work possible. The Climate Impacts Group relies on funding from public agencies and private individuals to support our staff, our science, our partnerships, and our community engagement. On behalf of the whole Climate Impacts Group team, a hearty thank you. So to kick off our first segment, which is about preparing our coasts and communities for climate change, I'd like to start us off with some background about sea level rise, why it's happening, and what it means for the state of Washington. So as you all know, human activities like the burning of fossil fuels, like coal, oil, and natural gas, are causing the climate to warm. And one of the impacts of rising air temperatures is that land-based glaciers and ice sheets are melting, causing sea levels to rise. The oceans are warming as well as the air, and as the oceans warm, they are expanding, which also contributes to sea level rise. Sea level rise is already occurring. So relative sea level rise at Seattle has increased about 9 inches over the last century. And more importantly, it's expected to accelerate. Because sea levels are a lagging indicator of climate change, we know we can expect significant additional sea level rise to occur, regardless of whether global greenhouse gas emissions decrease, increase, or stay the same. In other words, all of Washington's coastline is committed to some amount of sea level rise, regardless of the necessary critical actions we take to reduce our use of fossil fuels. By the 2050s, parts of the Puget Sound will see between roughly 7 and 14 inches of sea level rise. Parts of the outer coast will see approximately 2 to 8 inches, and the Olympic Peninsula can expect 4 to 10 inches of sea level rise. For those taking notes at home, these are just the central estimates. There's actually a real chance, 17%, that actual sea level rise could be higher than this. And the fact that seas will rise faster along some parts of our coastline than others is one of the reasons that our team recently released tools enabling Washington's communities to find data that's tailored to their specific location, helping them ensure they're planning for what is expected where they are. Sea level rise will exacerbate existing coastal hazards, such as shoreline and coastal bluff erosion, storm surge, and flooding. It poses threats to communities, ecosystems, and livelihoods around the globe, across the nation, and here in the Northwest. Sea level rise is expected to threaten public and private coastal properties, low-lying agricultural lands, roads, and other coastal infrastructure, and important coastal habitat. Washington's coastal areas and marine waters are an important economic engine for the state and provide an important sense of place and figure irreplaceably in the traditions and culture of tribal communities. Sea level rise stands to disrupt all of these. Tonight, we will learn about and celebrate efforts across the state of Washington to prepare our communities for sea level rise. Lara Whiteley-Binder, Climate Preparedness Specialist for, Climate Preparedness Program Manager at King County, will tell us about a recent effort to adjust zoning requirements to account for sea level rise. Courtney Greiner, marine ecologist with the Swinomish Indian tribal community will talk about how the Swinomish tribe is using indigenous knowledge and practices to prepare for rising sea levels. And Climate Impacts Group's staff scientist, Harriet Morgan, will join Laura and Courtney for a discussion of the takeaways from these efforts, what the Climate Impacts Group is doing to prepare the state for sea level rise, and how we move forward in building more climate resilient coasts. You can learn more about our panelists by using the link shown in the slide or the chat, or using your phone to scan the QR code. Now I'd like to turn it over to Laura, who will talk about the work of her team and partners in King County.
Thank you very much, Amy, and thank you for the opportunity to talk about King County's new sea level rise risk area as part of CIG's 25th anniversary event. We could go to the next slide. Thank you. King County sea level rise concerns include risks to the built environment and to our natural systems. Like many communities, we have low-lying public and private infrastructure that provides essential services. We have residential shoreline development, including development along erosion-prone coastal bluffs. That is, by the way, down here in this corner, a house at the bottom of that bluff. We have extensive nearshore habitat that's critical to the recovery of Puget Sound salmon and orca. And we have much beloved public recreation sites that are important parts of our communities. I'm seeing a message that they're not seeing the slides. Is that happening for others as well? Okay, great, thank you. I will continue. Next slide, please. In 2018, King County convened an interdepartmental team to review King County land use codes and policies and to develop recommendations for updating those codes as needed to account for sea level rise. A total of 35 possible changes were identified by the project team, and 17 were advanced as recommendations for implementation. My presentation today is focused on one set of changes adopted by the King County Council in July to address changes in coastal flood risk. I also want to note that this work was part of our 2015 Strategic Climate Action Plan, which is our 5-year strategy for guiding work to reduce greenhouse gas emissions and prepare for the impacts of climate change. Next slide, please. One of the major questions we wrestled with as a team was how to get ahead of the risk that is coming. When we look at coastal flooding, the regulations to address that flooding are tied to FEMA designated 100-year flood zones, which are the areas identified as having a 1% annual chance of flooding. The problem, however, is that FEMA floodplain updates are infrequent. Mapping can take 20 years or more. And these updates do not, at least at this point, include sea level rise. What this meant is that relying on FEMA floodplain updates to address changing coastal flood risks would in effect put us in the position of chasing sea level rise risk over time rather than actually getting ahead of it. So what did we do? Next slide, please. The first thing that we had to do was to decide how much sea level rise we were planning for. This is where we really benefited from the work of the Climate Impacts Group and Washington Sea Grant and other partners with the development of updated sea level rise scenarios through the Washington Coastal Resilience Project. The updated methodology used to develop those scenarios allowed us to explore our risk tolerance for sea level rise within King County and to ultimately determine on a range of values that fit what we felt was the appropriate range to manage for. That range was 2 to 5 feet of sea level rise. Next slide. We then turned our attention to our current floodplain regulations. Oh, I'm sorry, could you back up a slide? Thank you. King County has one of the strongest, if not the strongest, floodplain development requirements in the state. Most notably, if you build a new house or do a major remodel within the 100-year flood zone, the bottom of the first finished floor has to be at least 3 feet above the height of the 100-year flood. That is that red dotted line that you see on the figure. This means that if the water level in the 100-year flood is at 16 feet elevation, that bottom of the first finished floor has to be at least 19 feet in elevation. It's worth noting that most jurisdictions require 1 foot above base flood elevation. Some require none, some require 2. We are the only jurisdiction in the state of Washington to require 3 feet above base flood elevation. This was a change that was made more than a decade ago, partly in response to concerns about sea level rise and also recognizing some of the uncertainties around FEMA floodplain mapping. The key thing to note, though, is once you got out of that 100-year floodplain zone, you could build at whatever elevation you wanted. You could build at ground level. And the challenge, of course, is that as sea level rises, there's nothing magical about the boundary of that zone. The water will cross that line. There's no invisible force fields. So this, again, was this question of what do we do about development beyond the existing floodplain boundary, knowing that the water is coming? Next slide, please. In July of 2020, as part of our comprehensive plan, King County adopted a new sea level rise risk area. This extended our coastal floodplain development requirements into what is now known as the risk area. So now, new construction and major remodels built within that zone have to be constructed to 3 feet above the adjoining base flood elevation. This, for the first time, gives us the opportunity to get ahead of this risk. We no longer have to wait for the FEMA floodplain zones to be extended to start providing the necessary public safety protections for addressing sea level rise. In addition to the building height requirement, we also restricted the development of new groundwater wells in the coastal high hazard area, set surface seal requirements for wells within the sea level rise risk area to prevent saltwater intrusion, and increased setback requirements for development at the tops of bluffs that extend into the sea level rise risk area. Next slide. In many ways, this approach for the sea level rise risk area ended up being quite a simple solution to a very complex question and set of issues. And because it is tied to the FEMA flood zones and the boundaries that are delineated through that process, but going beyond that, it is a somewhat self-tending solution, which is helpful. As those floodplains do get updated, our sea level rise risk area will move back as well, always creating that opportunity to stay ahead of the defined problem. But one question, of course, is that enough? We have given ourselves some time to start addressing this problem, but there are more difficult decisions to be made. So there is considerable more work to be done. The nice thing about this approach, though, is that we do believe that it's a good model for other jurisdictions to consider, and to date have had several requests for the code so other jurisdictions can start looking at this. More importantly, I want to note that this is really the opening chapters of a story about how we address sea level rise on the King County shoreline, in this case, Vashon and Maury Island. There's more to be written, and I look forward to coming back and hopefully for CIG's next anniversary to tell you how that story unfolds. Thank you. Oh, sorry, my apologies. I'd like to now turn it over to Courtney Greiner, marine ecologist with the Swinomish Indian Tribal Community. Thank you.
Hi, thank you, Laura. My name is Courtney Greiner. I work in the Fisheries Department for Swinomish Indian Tribal Community. Before I begin, I'd like to acknowledge that I'm speaking from my home in Coast Salish territory on traditional Nooksack land. Thank you for the invitation to participate on this panel, and happy 25th anniversary to the Climate Impacts Group. Your work in close collaboration with tribal communities has enabled much of the climate change work that's occurring at Swinomish. So thank you for all that you do. Next slide, please. So my work at Swinomish Fisheries focuses on identifying and addressing climate change impacts on shellfish resources. One main concern is the loss of clam habitat due to sea level rise and increased wave energy. The Swinomish Reservation is located on a low-lying island near LaConner, Washington, and the area has already seen the damage rising sea levels can do when combined with extreme weather events. In 2006, water levels were several feet above normal during a couple of winter storms, which resulted in flooding, shoreline alterations, and community isolation. This got many in the community concerned, not only about future risks to infrastructure, but tribally important marine resources. Next slide, please. The loss of traditional harvest sites and decreases in clam abundance impact food security and the subsistence economy, as well as cultural identity. For the Swinomish people, clams play an important role in the moral and cultural belief system. Clam harvests provide opportunities for tribal members to exercise their treaty rights, access a nutritious local source of protein, and provide educational opportunities where elders can share teachings with youth that reinforce community values like stewardship and reciprocity. Next slide. In response to these concerns, we started looking into the ancient practice of clam gardening as a climate adaptation strategy. The practice consists of a variety of habitat enhancement techniques aimed to increase clam production. There are relics of this management strategy along the northwest coast of America, and some in British Columbia have been dated to be 3,000 years old. While the construction and maintenance of a garden is unique to its location and the individuals caring for it, there are some common features. For one, the typical garden has a low permeable rock wall that parallels the shore and is only visible during extreme low tides. Next slide. Over time, as sediment and broken shell fills in behind the wall, the beach flattens out, increasing the amount of habitat available at the optimal tidal elevation for clam production. Indigenous knowledge holders also describe tending and maintenance practices to promote clam growth and survival. Next slide. The benefits of these clam gardens appear to be numerous. Recent ecological studies have found that within historical clam gardens, the abundance and size of native littleneck and butter clams, which are two native tribally important species, are much greater than on unmodified beaches. Other fauna and flora also inhabit the beach and the rock wall, providing a local source for other edible species like sea urchins, sea cucumbers, and increase the presence of other habitat-forming species like kelp. Next slide. We believe clam gardens have a strong potential as a climate adaptation strategy. There's evidence that clam garden features can be adapted to changing sea levels by modifying the elevation at which the wall is constructed. Additionally, there's potential for the wall to reduce the intensity of waves hitting the shore and protect the upland area from erosion, as well as provide hospitable conditions for clams as seawater temperatures warm and acidify, all projected impacts from climate change. Next slide. In the last decade, there's been a push among coastal communities to bring clam gardening back into current resource management use. We have proposed to build the first clam garden in modern times on the Swinomish Reservation. Our goals are to maximize ecological and cultural benefits to the tribe, assess long-term effects of a clam garden on the nearshore environment, and provide an example for other coastal communities to sustainably increase clam production. Because clam gardening is an active management practice that requires both appropriate biophysical conditions and community engagement to succeed, the Fisheries Department and Community Environmental Health Program are collaborating on the project, and we're using a community-based participation approach. Next slide. Over the past 2 years, we've narrowed down the 3,000 tribally owned tideland acres on the reservation to just a handful of potential sites using a variety of ecological and sociocultural metrics. We've received community input on the top sites and presented the results to the Tribal Senate, who recently selected a location to build the clam garden. We are now completing permit applications and will begin collecting pre-construction data this coming spring and summer. We're also looking at funds to purchase material to build the wall and support community work events during which the wall will be constructed. We've got a long way to go, but we're really excited about the work we've conducted to date and the growing support for the project within the community. We've already heard from several tribal members on the importance of this work and the revival of Indigenous practices to promote traditional foods and increase community resilience to climate change. And we're really looking forward to beginning the transformation on the beach and furthering engagement in the community. Last slide. And of course, this is a massive project and could not be completed without all of these amazing people and groups and funders as well. Thank you.
Thank you, Courtney and Laura, for these interesting, inspiring stories, and congratulations, because you're both describing a lot of work and actual making a difference on the ground. So I'm looking forward to diving into more details, and I'm gonna begin by asking a question to Laura. Laura, the King County Risk Zone project is really an innovative first step in our region. Can you start by telling us what were some of the factors that made this work possible, or barriers to getting it done, and how you overcame them?
I think the new Washington Coastal Resilience Project scenarios were really key because it, for the first time, allowed us to get a better sense of the range of sea level rise and the probabilities associated with that. So it gave us a more nuanced look at what to expect. I think the other contributing part, of course, was the fact that King County has been working on preparing for sea level rise for, well over a decade. And in that sense, we had staff who were ready to engage on that, and we had strong political leadership that has prioritized climate change and has made climate change central to what we are supposed to be managing for as a county. So starting with Executive Ron Sims, who became the King County executive in the late 90s, through to Executive Constantine, who is now in his third term. We've had several decades now of strong leadership that has prioritized action on climate change. So it created an environment in which we were challenged in a positive way to say, what should we be doing? What do we need to be doing to address sea level rise? That created space for staff to take a critical look at our policies and our codes, and to have the courage to put forward the changes that we felt were needed to help address this risk. So those were a couple of key factors. Having SIG in our backyard was also extremely helpful because when we had questions, we were able to consult with Harriet and others about the application of this information to the types of decisions we were looking to make.
Yes, King County and Climate Impacts Group have been working together for a large part of these 25 years, I'd say. So Courtney, I'd like to hear from you on the same question. Maybe you could share with us some of the factors that have made, your progress possible so far, or if you'd like to share barriers or how you've overcome them.
Yeah. One of our main barriers was the fact that due to colonialism, deterrence to maintain traditional practices, and shoreline development, the knowledge surrounding Clam Gardens is very scarce. This is also the first known construction of a clam garden in modern times, so it's been difficult to know where to begin and how to proceed. There is a small but growing body of scientific literature, and there's some written and oral records, but we've had to rely heavily on partnerships with First Nations in British Columbia, who are working on the first clam garden restoration project with Parks Canada. So our first step was to create a technical advisory board where we brought a lot of knowledge holders and clam garden researchers just to help inform our process, to help us identify which metrics we should look at when identifying a site for a clam garden. And they've been incredibly valuable to our project. They've also provided a lot of lessons learned from the work that they're doing. And we've also had the opportunity to fund a few trips up to British Columbia for tribal members to participate at some of these restoration work events. And it's been amazing to have these tribal members work alongside First Nations members, relearning cultural practices, connecting with each other and the beach. It's done a lot for the support and the community, and been a big push for the project.
Thanks for sharing that. It's so inspiring to hear about what you're working on. I'd like to turn to Harriet. Harriet, you have worked on the issue of sea level rise up and down the coast. And I'm wondering if you could share a little bit about how the Climate Impacts Group is supporting sea level rise resilience in both Puget Sound and along the outer coast.
Yeah, I think Laura set me up really nicely to answer this question with her slides. So over the past few years, SIG has been an active member as part of the Washington Coastal Resilience Project. So this was a 3-year NOAA funded effort that the end goal really was just to rapidly increase our state's capacity to plan and prepare for natural coastal hazards. So like Amy mentioned earlier, these include things like shoreline erosion, bluff erosion, coastal flooding, wave damage. And we know that sea level rise is gonna just exacerbate all of those existing threats that we have here in Washington state. And so as part of this project, we partnered really closely with Washington Sea Grant and also Washington Department of Ecology. And one of the primary outcomes of the Washington Coastal Resilience Project was this updated set of relative sea level rise projections for Washington state that Laura highlighted in her presentation there. And what sort of makes these projections different from what we've seen previously in the state is that we actually developed 171 individual sets of sea level rise projections. So every 5 to 7 miles along the coastline, so this includes the Sound, the Strait of Juan de Fuca, as well as the outer coast, there's an independent set of sea level rise projections. And so these updated projections really enable decision makers who are, planning within their backyard or within a specific geographic location to use numbers that are speaking to their specific area on the landscape. So what we wanted to avoid was having folks doing some restoration work out on the outer coast using sea level rise data that was specific to Seattle. So we generated projections that were specific to fine scale areas along Washington's coastline. And these data are available for users to explore and to download through a Tableau visualization that Climate Impacts Group built out with the help of Tableau, and it's hosted on our website. And I think Tess is gonna send you all a link right now so you can go and explore that visualization for yourself. But basically what this visualization will enable you to do is explore these sea level rise projections through a variety of different lenses. So the first one that you can explore is geographically. So you can compare and contrast how projections vary across Washington's coastline. Second way you can view them is through time. So our projections go from the year 2020 all the way out to 2150. And so the visualization has some features to enable you to customize that future window that you're interested in. And then finally, you can also compare and contrast sea level rise projections across different greenhouse gas scenarios. So we generated projections under both a low and a high greenhouse gas scenario. And sort of since the release of the projections themselves, SIG has largely sort of pivoted our focus, harping back on what Amy and Lisa were talking about earlier, which is creating science that's really useful to and used by the decision-making community. So what we've been developing is a handful of reports and guidance documents with the main focus of ensuring that decision makers can actually take these data and apply them on the landscape to build coastal resilience throughout our communities. And I think, Laura, your case study that you highlighted earlier is just such a great example of what we're really hoping to achieve with this Washington Coastal Resilience Project. And specifically, one document I want to call out is one of our more recent ones. It's called How to Choose, creatively titled. It helps decision makers figure out what number they should choose for their specific planning project or their, whatever they're designing along the coastline. And so it's a 25-page report. We have an accompanying webinar to go along with it. And the intended audience there was climate adaptation specialists, coastal planners, engineers, other decision makers, and we really just wanted to lay out for them how you access the sea level rise projections, what the different subsets of the data are, and how you use them. How do you feel confident in the decision you're making about what timelines you're selecting, what probabilities of exceedance, like Laura showed in her slide, you're choosing for your decisions. And where do you land on using a high or low greenhouse gas scenario for those projections? And so I think to tie in to specifically answer your question, you mentioned both Puget Sound and the outer coast. And I want to be clear that these resources are continuous across Washington's entire coastline. They're not just for Puget Sound. They're for all 3,000 plus miles of our state's coastline.
I always forget that we have that many miles of coastline. It's amazing. Yeah, I know. It's all wiggly. And if you stretch it all out, it's a lot. Thanks, Harriet. And thanks for sharing those resources. There's a lot of really good questions coming in, and I'm not going to be able to get to all of them. So I will invite panelists who have the energy later to type in the chat some answers, or we will just collect the answers and share them out with our follow-up email. So apologies in advance for not being able to get to all the questions. But I have another one now that's for Harriet, coming right back to you. So we know that sea level rise is just one of several threats to coastal communities. And maybe you could tell us a little bit about what some of the other impacts of climate change on oceans and coasts are, and what we might do to prepare for them.
Yeah, that's a great question. We have had a heavy focus on sea level rise thus far, but coastal and marine ecosystems across our state are, expected to experience a wide variety of impacts from climate change. I think three that really stand out to me are increasing sea surface temperatures, increases in both the frequency and magnitude of harmful algal blooms, and also ocean acidification. So first, if we think a little bit about those first two, so sea surface temperatures and harmful algal blooms. So I didn't realize this before I moved here, but we actually have a handful of single-celled algal species in Washington that produce these toxins that can be toxic to marine animals and can also actually sort of accumulate in shellfish and can cause sickness, and in extreme cases actually be fatal when humans consume those contaminated shellfish. And so, like I mentioned earlier, climate change is projected to increase both the frequency and the magnitude of these toxic bloom events. And those are specific, that relationship is specifically tied to sea surface temperatures. So warming sea surface temperatures are projected to increase the growth rates of these algal species, and they're also projected to increase sort of that window of opportunity of when these algal or toxic blooms can happen throughout the year. So if you look historically, they may have occurred through this range of your calendar, but looking projected into the future with warmer sea surface temperatures, that range is expanding. And these toxic blooms can actually force pretty costly shutdowns of both sort of cultivated and wild shellfish harvests, which has a very significant economic implication for our state. So that's sort of algal blooms and sea surface temperatures. I think another really important one to highlight for Washington in particular is ocean acidification. So as a result of accumulating carbon dioxide in the atmosphere, we're seeing pH values in both Puget Sound and the North Pacific Ocean decreasing, and sort of that process in and of itself is what we refer to as ocean acidification. And as concentrations of carbon dioxide in the atmosphere continue to increase, we also expect the process of ocean acidification to increase and become worse as well. And so looking at projections for the end of the 21st century, projected increases in ocean acidity are on the order of 150 to 200%. So pretty significant. And these have very significant negative effects for a lot of Washington's estuarine species, specifically on their ability to reproduce effectively, on their growth, on their survival, specifically shellfish and calcium, organisms that use calcium to build their shells, a lot like what Courtney was talking about earlier. But I want to end with a happy secret, which is Amy's term, but that there's a lot of efforts to address these impacts related to coastal and marine ecosystems. And I think a really great one to call out is the Washington Ocean Acidification Center. So this is actually a EarthLab member organization. It was founded, I think, back in 2013 by the state legislature at the recommendation of the Blue Ribbon Panel on Ocean Acidification. And basically what that center is doing is super cool. It's bringing together researchers, policymakers, folks working in the marine industry, along with a slew of other individuals. And they're advancing the science on ocean acidification. And they're also basically just serving as a center that can create proactive strategies and policies around preserving Washington's marine environments and the industries that are working in that space. So I know that was probably drinking from the fire hose, but wanted to make a plug for some other stuff besides just sea level rise. And I'll note that Terry Klinger and Jan Newton are the co-directors for that center and can be much more articulate about the goals and missions and the work being done in that space.
Thanks, Harriet. I'm going to turn it back to Courtney. Courtney, I know that the Swinomish were one of the first tribal communities to develop a climate adaptation plan several years back now. Can you tell us about how the Clam Garden fits in with the broader Swinomish Indian tribal communities climate resilience work?
Yeah, so that climate adaptation plan was, as you know, and some others might know, that there's a collaboration with the Climate Impacts Group back in 2008. And CIG's provided all the technical support and the climate projections, and that really laid the groundwork for the tribe. Those potential impacts were shared with the community, and then the community created a bunch of goals to direct the tribe's work from there. So for fisheries, the Clam Garden project is just one climate adaptation strategy that addresses those community goals to restore native clam populations and diversity in marine biota. There's a long list of other projects that we're working on. We're trying to restore Olympia oysters to the reservation, which is an ecologically and culturally important native species that may also provide climate change benefits. Some of my colleagues have helped to develop the Pacific Northwest Crab Research Group, which is working to fill in knowledge gaps in just basic biology and population dynamics. And that will help inform Dungeness crab management practices and provide some information for climate change impacts. We're also increasing our ability to monitor local water conditions around the Swinomish Reservation, which is woefully under monitored, the whole Woodby Basin. So we're trying to address some of those gaps. And I'm also working on a climate change adaptation strategies report, and this will update the shellfish portion of that original adaptation plan. And one of the adaptation strategies is the Clam Garden. And then outside of fisheries, the tribe is doing a lot of work. The hunting and gathering program is looking at climate change impacts on deer and elk populations. The Skagit River System Cooperative, who works on behalf of Swinomish and Saxuatl tribes. They're doing great work to restore salmon habitat, streams and wetlands, and restore hydrology in Skagit Delta. The Department of Environmental Protection is working with homeowners on sea level rise impacts, and the tribes working to enhance their emergency response resources so they're better prepared for future flooding events and isolations and oil spills. So lots of good work going on, and a lot of the tools that CIG's provided are being used to help inform those actions.
Yeah, both your comments and Harriet's remind us that there are lots of concerns about climate change in the coastal area. I mean, across the world, of course, but even when we're just focusing on coast, it's not just sea level rise. There's lots of different factors. So I'm gonna ask all of you to tell me a little bit about where you hope we go. We've been talking about the really great progress that has happened, but let's look forward and say, what would you like to see happen in the next 3 to 5 years to really help make a big difference on additional progress on coastal resilience? And I'm going to start with Harriet.
Great. I'm actually gonna, I came up with 2 answers to this question, but I think based on what we just talked about, I'm gonna go with, for me personally, to stop thinking about planning for sea level rise in the sea level rise bubble, because you're never just planning for sea level rise, right? You also, what happens in the situation when you have a foot of sea level rise, it happens to coincide with storm surge, and a king tide, and you have local riverine flooding at the same time. So it's like, I think about it as layers of Swiss cheese, and what happens when all of the holes line up and you get this perfect storm event. how do we plan for those kind of situations where you have multiple climate stressors going on at once, sort of designing for those worst case scenarios, which, you know, in some cases are appropriate to plan for. And I'll also add on to that, I really just hope to see more folks getting out and trying to play with the sea level rise data and apply it into the projects that they're working on. And it's kind of a selfish reason for me, but the reason behind that is because I want to know like what we can be doing better, like where are the gaps, where are people getting hung up, so that we can increase the usability of this data. We did co-produce it with end users, but I think at the end of the day, people need to play in the sandbox with it to really get a sense of where the gaps are and where we can improve in the future.
Thanks, Harriet. How about you, Laura? Where do you want us to go?
I think what I'm really looking forward to is having more of our federal partners participating in climate preparedness and being at the table. I'm really looking forward and excited by the incredible focus on implementation. I feel that over the last 15 years or so, there's been this groundswell of effort to really help define the scope and scale of the problem that we're facing at community and state levels and at the national level. And you know, we've got, there will always be questions that we need to answer about that. But we're now ready to start asking and are asking the more complex questions that come with actually moving to action on this. So I think that there's an incredible amount of opportunity to start, and it'll be exciting to see how communities and state and federal agency partners and research groups like CIG can partner together to actually start making some of these on the ground changes that we know we need to. We've got our list of to-dos. Now it's time to start tackling that to-do list and seeing where that takes us and what we learn from that, and then how we can feed that back into continued work to really push on this wicked problem of preparing for climate change, you know, working within a dynamic environment and a rapidly changing environment. And I'm confident that we can do it. I'm the eternal optimist, but I know we can do it. And I just love the idea of having more and more people rolling up the sleeves and kind of pushing on this stone.
Yeah, we all need to have our shoulder to the boulder, right? Is how I think about it. Thank you, Laura. Courtney, would you like to share with us where you hope we can move to now?
For me personally, kind of similar to Laura, I'd like to see stronger policies and more financial support from the federal government to enable more action at the tribal, state, and local levels. You know, addressing climate change is very expensive, and it's only going to get more expensive. And a lot of native and non-native communities just don't have the resources to take it on. And other communities just need more incentives to actually make the hard decisions to truly protect their residents and resources. And for tribal communities, the list of options is already limited because of the set boundaries of reservations and fishing rights, and they're already impacted from a number of different factors, the years of oppression, and their strong ties to the land and the resources makes the impacts much greater than just it impacts their entire health and well-being, mentally, spiritually, emotionally, and physically. So having the federal government really step up and support communities would be really great to see. And I think actualize a lot of work that folks know needs to get done.
Yes, that's absolutely right. I totally agree. We made a lot of progress. We have a lot more to do. So thank you, all three of you. Thank you so much. We could have gone on forever. I mean, for much longer, because this is really fascinating, and I'm sorry we couldn't get to everybody's questions. I definitely, I found this really powerful, just thinking about these ways that we connect science and community values, and think of ways to respond to the threat of local impacts of climate change in a way that like restores and rejuvenates the things that we hold in common and the values we have. Thank you very much. So let's turn to our next topic, which is wildlife and climate change in the Northwest. So as we know, as the climate changes, critical features of our landscapes are changing too. And for some species, this means that the habitat they rely on is slowly disappearing or shifting toward other regions. For example, in the Cascadia region and other parts of the Northwest, wolverines rely on persistent deep spring snowpack for raising their young. As the climate warms, less snow is falling in the Washington Cascades, and the snow that does fall is melting earlier in the spring, meaning the wolverines are losing valuable habitat. And it's not just the wolverines. Other Northwest species like lynx and sage grouse are losing critical habitat as temperatures warm and landscapes become more fragmented by the cumulative impacts of climate change and land use. So tonight for our second panel, we're going to hear from 3 experts on efforts to conserve landscapes in the Cascadia region to better support species and wildlife in a changing climate. We're joined by Dr. Jason Ransom, wildlife biologist at the North Cascades National Park, who will talk about grizzly reintroduction, the efforts in the Cascades. Jen Watkins of Washington DNR, Department of Natural Resources, who will discuss the ongoing efforts of the Cascadia Partner Forum, and the Climate Impacts Group's own Dr. Mead Crosby, senior scientist, who will tell us about how our team, who will tell you, I know, about how our team is working to innovate and contribute to these efforts. So Jason, please take it away.
Great, thanks, Amy. And thanks for having us here tonight. This is a great panel and really excited to be here. I'm going to talk a little bit about one of the tools we're using to think about grizzly bear reintroduction, and maybe more broadly why reintroduction is a tool that we even think about. And part of that is building resilience through biodiversity. I mean, in the simplest terms, you know, the more original players of the ecosystem you have, the better chance you have of dealing with change through time. And as I talk about this grizzly bear tool, I want to recognize there at the bottom of the screen my collaborators who are not Park Service, all from different organizations actually, but Andrea Lyons, who carried a lot of the modeling heavyweight on this, Catherine Hegewisch, and Mead Crosby, who we're going to hear about later. Next slide, please. We do look at an ecosystem perspective from the Park Service lens, where the National Park Service complex is that sort of wedge in the middle of the map there that's darker shade. It is a transboundary ecosystem that's quite big. I mean, 20,000 square kilometers is actually one of the largest intact wilderness areas in the contiguous US. It's a big palette to work with when we think about how do we manage this. And we're fortunate that we have almost a completely intact historical assemblage of animal species. And by historical, we're probably talking millennia, except for a few players. Fishers were extirpated by humans sometime in the last century. Turn of the century, took a lot of pressure, but they were wiped out for the fur trade. Over the last 2 winters, we have released 89 fishers back into the North Cascades. And as we speak, they're out there being fishers and hopefully making their way back into our ecosystem. Cascade red fox are not in the core part of this ecosystem, but they're still around in the state. And in fact, you can see them down at Mount Rainier. So they're around, and we're trying to figure out why they are and aren't where they are. And then grizzly bear is the last big one. And it's a big one because it's considered a keystone species. And by keystone, we mean a species that really has sort of an outsized effect on the ecosystem around it. And grizzly bears are just gone. So next slide, please. So the first task we did was to take a deep dive into sort of what do we know. And you'll see on the left, there's a cover of a report we released a couple years ago. If you can see on the bottom of the screen, irma.nps.gov is the sort of data and publication clearinghouse where all this stuff is open access. So there's a big document where we did a deep dive, talked to tribes and First Nations. We dug through all sorts of historical records and fur trade records and everything else to say, were they here? Where were they? How many were there? And as you could guess, it's, you know, it's a piecemeal sort of thing because the trail is thin and we don't have data on existing grizzly bears in this ecosystem. But the spoiler is, yes, they were here and now they're not. The last confirmed record was a single bear in Manning Provincial Park in British Columbia in 2015. There've only been 4 confirmed sightings of grizzly bears in this ecosystem in the last decade, and we're pretty sure most of those are the same individual bear. They're functionally extirpated. There's no breeding. There may be a few animals out there somewhere. The second part of this equation on the right was a deep dive into sort of what resources are here that grizzly bears would use based on what grizzly bears use everywhere else, which is our best tool, right? To look at similar ecosystems and say, what do grizzly bears eat? Where do they live? What do they need for denning? What do they need seasonally? And we looked at sort of the climate change, the broader sort of qualitative ideas on climate change effects that this ecosystem might see. And when we crosswalked all of the data about science and diet, we came up with 2,500 plant and 450 animal species that we know are grizzly bear foods or related to them. And so, yeah, we think there's ample resources here. Next slide, please. And so we did this tool where we crosswalked a few different modeling platforms. And so on the left, we said, what do grizzly bears need? And we looked at a resource selection model developed on the transboundary with Canada, where they do have bears. And basically there's these 5 things: this sort of index of greenness, the openness of the canopy, the alpine vegetation, the riparian or near water vegetation, and elevation, and then this important factor of how close are all these things that grizzly bears need to roads, because roads have a negative effect on bears across their range. The second step in the middle was, what will this ecosystem provide in the future in terms of those things that grizzly bears like? And we looked at really 36 combinations of things, but it's 20 global circulation models, a low and high greenhouse gas scenario. And we put them all in this MC2, this dynamic vegetation model, to say, if you can throw all this stuff that we know bears need into the future, what does it look like in the future? And the last part is the easiest wildlife reintroduction, is just to create imaginary bears in the computer. So we created these cyber bears and we dropped them into these vegetation models with all these future scenarios. And we used 2 different flavors of bears. We used established females that have a home range. We used 3 different sizes based on the known literature on what sizes bears pick in other ecosystems. And then dispersing females, which don't have a home range. They're dispersing. They're trying to find their place in the world. And so we put all these imaginary bears in the ecosystem. We let 50 years elapse for them to sort of settle out, kill off all the extra bears, let the ones that live there set up shop. And then 100 years of just simulated living in the ecosystem through these different models of change. Next slide. And what we found was really surprising. This is a busy map, but if you look at the broader spectrum here, the yellow and gray is sort of poor quality habitat, and the green and blue is better quality habitat. And what we found is that sort of worst case scenario, 77% decrease in the bad habitat, but 197% increase in the good habitat. And so if you look at the bottom row of that, that's the 20 model average. And on the very far left would be the lowest emission scenario in the near term, the 2050s. And all the way in the bottom right would be the highest emission rate through 2099. And what you can see is that darker shade of good habitat really is pervasive. And so the high quality habitat increased across all the scenarios and all the models through all the time periods, which is really positive for grizzly bears. Next slide. And in terms of what that means for how many bears could live there, in the current world right now, if there were magically bears out there, we estimated that this ecosystem would support about 139 females. And so if you assume a 50-50 ratio, then that's about 280 total bears. If you go to the future, of course, there's a whole spectrum of models and scenarios, but roughly the carrying capacity would jump up to 241 to 289 females. And so in the map terms there, which is on density, we'd go from a current situation of about 17 bears per 1,000 square kilometers to 20 to 22 bears per 1,000 square kilometers. So again, on that bottom row is the 20 model average. On the bottom left would be the lowest emission scenario in the nearest term, the 2050s. And the density there is sort of in the core of the habitat, 9 to 10 bears, female bears per 1,000 square kilometers. And then on the far right bottom, again, you have the sort of worst case scenario. And you see the density goes up in the middle of the ecosystem. And I'll point out across these scenarios, we see the density is low and goes down a bit around the edges, and especially in the east side edge of the ecosystem. And so there's sort of an added bonus at a finer scale here, which is that the better habitat moves up in slope, up in elevation, which fundamentally pulls bears farther away from people because we tend to live and farm and have roads in lower elevation. So there's a couple silver linings there. Next slide. This is the last slide, actually. And so through this exercise, we can say that, yeah, grizzly bears are actually climate change winners in this ecosystem. And so that's great, but they don't exist here right now. And so they have to exist for them to be winners. If we could put them back, we might realize this fairly major piece of biodiversity that this ecosystem has been lacking due to humans extirpating them. Unfortunately, they're not likely to return on their own. If you look at southern British Columbia, grizzly bears are wiped out. There's no contiguous relationship with the Rockies or northern British Columbia bear populations. So if we wanted to put them here, we'd have to physically put them here. And I'll point out lastly that ecology is not the same as coexistence. We can do all this work and we can say this is great habitat and we can put bears here, but that's not the same as living with them. And when we talk about putting large carnivores back on the landscape, it requires, you know, a broad array of stakeholders to say, can we do this? Should we do this? And then how do we do it right so that we all benefit from it? And there's lots of question marks there that I'm gonna have to leave you with because we have limited time. But that's where we are working towards thinking about this big action. And I'm going to turn it over now to Jen Watkins at the Washington Department of Natural Resources. Thanks.
Jen, you might be on mute.
Oh, wonderful. First tech issue of the night, and it was me. So thanks everybody for putting up with that start, a little bit of silence. Thank you, Jason, and thank you to the Climate Impacts Group for letting me be a part of this important celebration tonight. I have had the great fortune of working alongside several Climate Impacts Group scientists in the Cascadia Partner Forum. That's a group that was formed in 2012 by natural resource practitioners on both sides of the border in Washington and British Columbia that simply realized we needed to work together across traditional boundaries of land ownership and international borders to facilitate and build the adaptive capacity of our shared landscape and the species living within it. And tonight, when I was asked to provide a story about wildlife and resilience, I thought I'd just actually tell a story of where I saw the ethos of the Climate Impacts Group of applied science really play out and offer hope and teach me some lessons along the way about resilience. I'm going to move a little further south than Jason in the Cascades and also talk about a project that really aimed to have progress for all of these species we're looking at on the screen. From that charming pika holding a whole lot of grass in its mouth to the Canada lynx, moving so smooth with those snowshoes for feet across the snow, to the Pacific giant salamander and the elk. And next slide. We have had scientists, and in this case with the map that you're viewing here, the University of Washington and the Nature Conservancy help us understand that when we think about the climate impacts that are going to be coming at us, at a continental scale, we know that wildlife need to move. And with a graphic as beautiful as this, we've even begun to understand the broad patterns of how they move. But next slide. We're even more fortunate in Washington, on the next slide, to have the climate impact. Nope, oh, sorry, previous slide, it just moved a little slow. In Washington, we're even more fortunate to have scientists like the Climate Impacts Group, as well as the co-production of collaborative scientific bodies like the Washington Wildlife Habitat Connectivity Working Group and the Cascadia Partner Forum, where we take that continental level science, the huge science of climate change at the scale it's happening, and it gets drilled down to something we know how to act on here in Washington. And so the text on this slide, it is verbatim pulled from a Climate Impacts Group report that actually synthesized all of the science about how climate is going to impact our species and helps us understand that idea that they need to have those options for movement. Also on this slide is one of the many maps created from the Connectivity Working Group, where we not only know that wildlife need to move, scientists began to map for us to help us visualize how and where are they moving, where is the best available habitat, and what is the resistance for how they move between that habitat. So not only do we have a way to anticipate that, but for people like myself who've been in the nonprofit community and now in a state agency, I can understand where I can invest and act to facilitate those changes today and over time. And my story today is going to start in the blue area, right there in the central Cascades, about an hour east of Seattle, where it's that connective tissue between all that green, wonderful habitat in the Cascades. So the next slide. About 20 years ago, when CIG was about 5 years old, I began working in the Cascades in the landscape just east of Snoqualmie Pass along I-90. And when you get this bird's eye view that we're looking at here of Snoqualmie Pass, the Cascades seem wild and rugged. The habitat seems intact, but even there, you see this ribbon of an interstate that acts as a bit of a barrier for wildlife. So we know that something's breaking up that habitat. And next slide. When we step down from that bird's eye view to the view that an animal actually gets adjacent to I-90, this is a photo that the Department of Transportation actually took of an elk viewing freight moving across I-90. That's where we see that ribbon that we saw at another level actually acts as a huge barrier for wildlife having that ability to move. And the good news for this elk and many of the other species, including those I showed on that first slide, is that over the past 2 decades, a remarkable story has unfolded, where a highway that acted as a barrier for wildlife movement, it's undergoing profound change to improve east-west connections for people, like all of us on the line here, to move in our cars across Washington. It's also improving those connections for wildlife, including this elk, to move north-south in the Cascades. I entered this story about 20 years ago, right as I was leaving college. And I learned a few things along the way, not only about how we can work together to increase resiliency for ecosystems and wildlife like we're viewing here, but also how we can increase some of our own resiliency in doing this work. Because when I say something has taken 20 years, it takes a while to do this work, and we all need to stay in it. So we need to make sure that we can keep ourselves resilient. Next slide. The first lesson I learned, which can seem kind of ridiculous, is that when we talk about climate change, the issues are huge, and the solutions we need to come up with have to be equally huge. And so on one side of the screen, we're looking at the wildlife overpass that actually has been constructed and is currently being planted over Interstate 90, which is a tremendous, big structure to help wildlife move. But one of the coolest things I found is that when we're dealing with these big issues, we have to remember that we bring along and think about the smallest of our creatures. The little ones have to be thought about. But at the same time, we have to find wonder. And for me, that ended up happening in some of the smallest creatures we thought about for this overpass. Right here is the Dromedary jumping slug. This fascinating creature carries all of its internal organs in that backpack it's actually carrying. And when it actually gets disturbed by a predator, it does its signature move that it's named after by just kind of jumping and flipping itself. And so while dealing with all the decades of thinking about how do we plan for this wildlife overpass, what do? We ended up looking at what species we were building it for. And when we found this jumping slug, I found myself in awe of the evolution that this thing even exists in the forest that we live by, that something actually carries all of its organs on its back and survives in this world. And it turned out with research that a lot of species about this size with small amphibians, they don't just cross that overpass in a matter of minutes like an elk does. they'll end up living on that overpass. And so it makes you think differently about the solutions that we create. So I guess lesson number one, remembering that we've got to solve things for everybody. We've got to solve them even for the smallest of creatures. And we can't forget to find a little bit of wonder and awe along the way. Next slide. The other thing I learned in the I-90 project, and right here we're looking at one of the underpasses that was built at Townsend Creek. There's a whole series of them that were built on Interstate 90. The thing I learned is how quickly wildlife will respond. There's that famous Hollywood line, build it and they will come. And we saw that in I-90. Here at Townsend Creek, we ended up seeing bull trout respond nearly immediately once that structure was opened and the flow started happening for that creek. They had returned into tributaries they hadn't been in decades. They had been cut off in the original construction of I-90, and immediately upon opening, when you thought that sedimentation or other issues might prevent them from coming in, these curious creatures came in right away. Also on this slide, we're looking at a Chinook salmon. These salmon had that same response, and while we were monitoring, we were able to actually put tags on them, the scientists at Central Washington University. And with those tags, we were able to see them leave the tributaries right there at Snoqualmie Pass and travel over 130 miles past the John Day Dam out to the ocean. And so watching their response, knowing how rapidly that if we offer them options, when we decide to do the right thing and change this landscape and give wildlife a chance, they will respond. Next slide. And it's not just the fish and the little ones. These are elk. This was just a month ago of elk. You'd hardly know it, but they're standing right on top of I-90 on that overpass. And to me, I'm looking at two of them that appear to be having a pretty good time, and none of them appear to be stressed about the traffic underneath them. And as you'll notice, this is before the forest even begins to really regrow on that overpass. And so right as that overpass was built, even while construction equipment was up there, they saw that deer were beginning to bed right next to the construction equipment. And some of the guys who are coming in for that construction the next day were getting photos on their phone. And now as the equipment is left, we're seeing entire herds of elk moving over I-90 and taking their time in doing it. So lesson number two, wildlife will respond and it'll happen quickly if we just offer them the chance. Next slide. One thing that really stood out to me in the I-90 project is that while we as professionals who had studied not only wildlife and all of the ecosystems that we were trying to connect, but getting together with the engineers who had studied for years how you actually make rebar and concrete, produce the kinds of structures we were discussing, we felt like we were pretty on groundbreaking turf thinking about these wildlife overpasses. And as we began to reach out to elementary and middle and high school students throughout Washington about this project, they got it a lot quicker than we did. And it made sense to them a lot quicker than it did to us. And so I guess the next lesson I just wanted to share is the power of the next generation coming up under us, how quickly they're understanding the issues of climate, how quickly they think of creative and large-scale solutions to solve this, and the level of inspiration they've got behind this, it gave me a hope as much as the actual construction itself did and the wildlife response. And so right here, we're viewing not only some of the artwork they did, that's actually some of the constructions they did of how if they built an overpass, what they would include in it. And some of them were novel ideas I hope we see in our next connectivity structures in Washington. Next slide. This slide is just a reminder. This is myself standing on the overpass right after it had been constructed with a colleague from the U.S. Forest Service. And it's a reminder to me that although we may be designing these and the idea and thinking about species and their needs, none of this happens without people. People who are willing to think a little bigger, to stand their ground, to put out bold ideas that may seem a little crazy at first. And the woman in this photo, Patty Garvey-Darda, she put out a lot of big ideas alongside other colleagues for the I-90 project before anybody thought they were logical. Her first idea was actually to just build one big bridge for the entire 15 miles so that no animal had to worry about anything. They just walk underneath it. And after she kind of got crickets from a lot of the engineers about how impossible and expensive that would be, she backed up to ideas that still seem bold but are becoming reality in front of our eyes. And so I just think the relationships that we build, whether in practice or in our areas like the Cascadia Partner Forum, they matter because it's the people and the relationships we're going to need to get the resilient work we need on the ground done. Next slide. And my final lesson in all of it is, although the I-90 story was an amazing one to be a part of for myself, it was a chapter. And as we think about doing resilient work here in Washington and throughout the region, it's a long haul of a story. And there's always another chapter to be a part of, and there is also a lot of roles to play. And so for myself, a year and a half ago, I moved to the Department of Natural Resources from my previous nonprofit job. And while I stepped away from working directly on I-90, although I got to maintain my engagement in a lot of the exciting regional bodies like the Cascadia Partner Forum, I ended up working for an agency where I get to work on the forests and their resiliency immediately adjacent to I-90 and think about how that habitat can actually act as a healthy feeder habitat on either side of these crossing structures, and then connected to these wilder places like Jason was talking about at North Cascades National Park. And so I just close saying, I think there is a lot of hope that has been done out there. And I find myself excited not only about the stories that we've completed together on the landscape and how wildlife are already responding, but the stories we have yet to tell and how much more work there is to be done. Thank you for having me tonight.
Thank you, Jen, and thank you, Jason, for sharing those stories. This is really great, exciting work, and it's going to be really fun to dig into it a little bit more. And I just want to say that I think we have a lot of awesome content tonight and a lot of stories to tell. And people might be seeing we're running up close to our advertised stopping time. But the miracle of the interwebs are that we are recording this and we are just gonna, we might spill over a little bit. And so if you had to leave us at 7:30, you will be able to click back on next week and find the ending comments from folks. So never fear if you have to leave before we finish. I'm going to start by asking Jason a question. So your story is about one instance of reintroducing a species to a region that it used to inhabit. So what does this study tell us about whether or not we should be reintroducing species in a changing climate?
That's a great question. But let's be really clear about wildlife reintroduction. It is the last option when all of the conservation has failed. It's the last thing we have in our bag. It's difficult, it's risky, it demands extraordinarily animal welfare consideration. It's not as simple as putting back a missing piece of a puzzle. And the reality is that while we're working to understand how this ecosystem will look in the future, it was also different back when these species were extirpated. It's a continuum in time, right? So we can't drop a bear from the 1800s into the 2000s North Cascades ecosystem and expect it to be the same bear in the same ecological space. That's not realistic. So reintroduced animals have to carve out a new place in the ecosystem. And if our models are correct, then they'll have the resources they need. So our main goal is to restore the biodiversity that was here and give our ecosystem a fighting chance to survive large-scale change. But it demands really careful thought and science-driven management. We can't just assume it's going to work and say, oh, let's try it. We have to do this work. We have to do the modeling, use the best science we can use, and sort of hedge our bets. And then weigh that against all those things. So what are the implications with people and with other species? And like what's going to displace what and where's it going to go? Those are big questions, and it takes a lot of careful thought. So yes, we can reintroduce species successfully in a changing climate. But it doesn't mean we should reintroduce all species. Some are not climate winners, some are. So yeah, it's a complicated picture.
It is really complicated, and it's complicated when you tell us about a species that's a climate winner, but it can't win if it's not there, right? I mean,
right.
That was really powerful. This one's for Jen. Jen, can you tell us a little bit more about the Cascadia Partner Forum in terms of what some of its strengths are, and what challenges it's currently thinking about tackling?
Yeah, absolutely. I touched on them so lightly. This remarkable transboundary forum is led by a leadership council of about a dozen individuals from both sides of the border, agencies, tribes, First Nations, nonprofits, and scientists, including those big as well as on the British Columbia side of the border from universities. And it supports a much larger network of individuals on both sides of the border working on these issues of how do we think about resiliency for natural resources. And I think one of the greatest strengths is that every organization has a foundation story. And for the Cascadia Partner Forum, it is a very organic group of individuals who chose to start gathering once a year, realizing that we couldn't solve our challenges by ourselves or at the tables we were currently sitting at in our roles. We had to think outside our boundaries. And it's grown from that very organic story of individuals. But because it was driven by those practitioners seeing a need themselves to accomplish their goals, it has always had an application of all of the science and priorities we identify. And so that's exciting to me because we get that matched with the power, and I cannot underscore enough, the power of the science community that we get to work with. And so you have this need that is constantly sitting there from the practitioners on the ground, married to the scientists who can give us the tools, the information, and translate it in a way that we can act on. That's the greatest strength. The greatest challenges I see is this landscape is so dynamic. Our region is changing right in front of our eyes constantly. And so whether it's where a house is built, whether it's how big the wildfires are impacting the landscape every single year, it is changing. And our ability to plan and dynamically change our plans as quick as the landscape is changing is a huge challenge. And so that's one I think we need to address, but I think we've got the people and the tools to do it.
I think we run the risk of, or we're all trying not to get stuck in what Laura was saying, which was sort of, well, let's say it a different way. She was saying the challenge is to get ahead of climate change and these other changes, not to just keep chasing them down the road, right? And so this is another good example of that. So I'm going to bring Mead in. Mead hasn't had a chance to join the conversation yet. So Mead, maybe you could tell us why you think it's important that stakeholders from across boundaries come together to work on these projects.
Yeah, so I feel like Jen and Jason already set me up very well to do that. You probably all know the answer now, which is that the impacts of climate change don't start at borders. The response of our natural systems to climate change do not stop at borders. And so our response can't either. The scale at which we're seeing impacts of disturbance like fires and floods, the scale at which our natural world is responding, we know that species are moving across our landscapes to respond to climate change. That's how they adapt. It's how they've always adapted to changes in climate in the past, but now the climate is changing so quickly, and they have so many things in the way. There's roads in the way, and there's cities and farms, and there's all of these borders of jurisdictions. There are international borders here in the Northwest between Washington and British Columbia, the US and Canada. And so we can't, the wildlife, they don't see those borders, and they need to move past them. And so we have to be working as a large landscape to respond and to make sure that we have a connected, resilient landscape to give them their best shot at getting to where they need to go, and that there's going to be habitat there when they get there. We also need to be leveraging each other's knowledge and expertise and resources in doing this work. So really no individual jurisdiction or land ownership is going to be able to meet any kind of conservation mandate alone in a changing climate. They're going to have to be learning and working with their neighbors, sharing information, sharing resources, and really thinking of themselves as part of a larger landscape that all has to work together to give our wildlife its best shot.
You know, I think what you're describing, I think folks who have worked in or with different government agencies or management agencies know how hard it can be to, or how it's not necessarily in the normal scheme of things to collaborate across jurisdictions. But it strikes me as when you're describing this, it sounds like, yeah, it makes sense, right? We should all work together across the landscape, and we don't realize that, you know, people in a state agency probably can't travel to a different state to meet with people in the similar state agency. We also have problems crossing the international border. We already did, and now we really do, right? And so I think what's so exciting about the Cascadia Partner Forum is this providing an opportunity, a forum for people really to connect in a way that doesn't happen otherwise. So I guess this is another question for me that sort of expands on that. Just maybe tell us a little bit about why Cascadia, right? Why is this work focused here? Northwest is a big place. I mean, I think we described Cascadia as sort of, think about the backbone of the Cascades going between Washington and British Columbia, and you know, the parts kind of attached to that, but the Northwest is bigger than that. So why Cascadia?
So again, Jason and Jen set me up so well for this. So if you like close your eyes and have a mental image of their slides again, and picture for a moment that slide, Jen pulled up a slide that had a big green blob right down the middle of the map where the Cascades are. And what that slide was showing was the connectedness of healthy landscapes for like habitat for wildlife where they could move freely, right? And so those are the Cascades. We have this amazing corridor, this north-south corridor and an elevational corridor running right smack through the middle of Washington and British Columbia. And so as species respond to climate change, they're all responding in their own way. They're all responding to different cues, but on average, they are moving upward in elevation and upward in latitude to respond. They're trying to track the areas that are climatically comfortable for them, and those are moving away from the equator towards the poles and upward in elevation. They're trying to stay cool as it warms up, right? So they're going to cooler places. The Cascades is this amazing corridor. It runs straight north and it has tons of elevational relief. So species have opportunities to move up in elevation, they can move north, and it's in good condition. And as much to pay this much attention to everywhere on the landscape right now, and there are people working all across the Northwest in all different landscapes at all different scales. But the reason that we are focusing on what we're calling Cascadia, the Cascade Crest, and the Cascade Range, and on either side of that, from Washington into British Columbia, is because it's land that's already in really good condition. It's much easier to maintain than to restore. And there's a lot of public land in there. So we know the partners. It's much less complicated than dealing with a large landscape that's largely in private land ownership. So it's tractable, and it's a really important area for a climate movement and refugia. So in addition to moving northward and upward, like those amazing slugs that Jen telling us about with their little backpacks, they're going to have a hard time trucking all the way up to British Columbia, right? From wherever they are. Maybe they're already up there. I don't know their range, right? But there's little guys who can't move very far. And so for little guys with little ranges who are not wolverines and can't just book it 100 miles, north when it gets too hot, we also need little refugia areas that'll stay cool for them, where they can hang out while we try to fix our climate problem and get this under control, right? And the Cascades, in addition to being this corridor, it has a lot of different microclimates. So there's north-facing slopes and south-facing slopes. There's valleys that can store cool air. There's all kinds of different climates in there, and a lot of high elevation. And so it's also, it could be potential refuge for species that can't move that far on the landscape, where they could hang out and hunker down till we turn the ship around.
Thank you. Thank you. Jen, can you tell us a little bit? We've been talking about, I guess, the good news, but maybe you could tell us a little bit about where you think the work to conserve wildlife in the face of a climate change is falling short, and where we need to do some more work.
Sure, I'll happily bring it down for just a minute. I think the first thing, going back to Jason's presentation as a great example, is that we have to admit wildlife can't respond to more challenges coming their way if they're barely hanging on today. If we don't have a population, if we have populations that are tiny and fragmented, we've got to get them resilient today to handle more things coming at them in the future. The next one, that's the low-hanging fruit you hear everyone say, is, I need more money. We have got to be able to support and tell our elected officials and free up the resources to meet this challenge with the resources it needs. And I don't say that for the implementation of things as exciting as a wildlife overpass. We have to fund the capacity of the people who herd the cats and bring us together to come up with these solutions. We have to fund the science that tells us where we're going to work and how we need to do things. And so we have to fund the stuff that's not as exciting to come up with funding the huge things that really matter. And all of that is going to add up to something more resilient. And last, and I put this on myself and my colleagues on the panel tonight, we have to get out of our silos. And I see it as something we're already starting to do, but climate change has really challenged us. We've done well for decades and decades, but the carnivore folks love the carnivore folks. Fish people talk to fish people. If you work in the forest, you work in the forest, and people who work in the grasslands and shrubs that stay there. And what we're finding is climate's blurring all of those lines. And so we've got to start integrating across all of those lines and finding not only how do we prepare for the changes we barely see coming, where lands are expanding up into what is once forested, but how do we find that magic sweet spot where the place that you needed to do drought mitigation and salmon recovery is right where I need to be to increase forest health and maybe improve that food source for grizzly bears. That's what we're going to need when the dollars are scarce and the challenge is so big, is tearing down those silos, finding a way that we integrate across all these interests. And you know what, for all of our scientists and practitioners like me, don't give up your passion about your species or your specialty. Just find a way that we can integrate so we can get a lot smarter about how we're doing things.
I'm going to let you tag on to that, Jason. You're working in North Cascades National Park, and grizzly reintroduction and analysis is only one issue that you're dealing with. So maybe you could tell us a little bit more about your goals in conservation as the climate warms, as a steward of public lands and wildlife.
Sure. You know, national parks are really unique federal lands because we don't generally have a broad multi-use mandate like so many other lands do. Yeah, North Cascades has recreation, of course, and we have hydroelectric, so there's some things going on there. But, you know, in general, if you look at the Organic Act across all the national parks, you know, what we do is preserve special places. And in the case of North Cascades, the park serves as an anchor. It's like right in the middle of this ecosystem. It is that refugia for a broader conservation landscape, right? So I'd say, you know, our conservation goals in a broader sense are, one, to preserve what we have, and in largely an unmanaged way. You know, let nature take its course. We let fires burn. You know, we let nature happen. But we also, another goal is to restore the species that were lost due to people. You know, if we cause them to go away, then, you know, we need to make reparations and we need to put those things back. And this is the sort of non-glorified one, but we have a really, I think, important role in national parks to document how ecosystems change through time. And that's not very glorious. It's not like an action item. But parks make really good natural laboratories, right? I mean, we often can serve as a control, sort of in an experimental sense, because all the lands around us are managed in so many different ways, and yet here's this piece that's going on. And I think that's a really important piece that parks can add to the conservation story. And I'd say overall, if we do our jobs as good stewards of national parks, this place will be here for future generations. And however it might look different, the difference should reflect a function of nature more than a function of man. I think that's the ultimate goal.
Yeah, the North Cascades are one of my favorite places in the universe. So I'm glad to hear of that optimistic statement. So we're gonna wrap up with the last question. And it's a question for all three of you. And if you could just give me a short answer as to your current thoughts on what you'd like to see happen in the next 3 to 5 years to really make a difference on building resilience for wildlife and ecosystems. How about, let's start with you, Jen.
I guess the first thing I'd really love to see is repeatability. We heard a lot of great things tonight that are happening, whether it's at the county level, like in King County, or at the individual park level on species. I'd love to see repeatability, that we don't just talk about these nuggets in 3 years, but we're seeing them actually take lessons learned and repeat throughout our area. I would love to see that. And amongst our colleagues who are doing this, and I hope the community grows, who's working on climate resilience as it embeds in all of our work, I think about a couple of traits I hope we've got in 3 years still. And 2 of them to me is that integration I spoke about, and the grit. The resolve, the courage, and the strength, that sheer grit to keep going when you do feel overwhelmed about climate change, but you believe in this enough and see where we can go.
Thank you. Jason, how about you?
I'm gonna echo what Jen and Mead already articulated really well is that I think looking near and long term, we need to continue to foster and build the Cascadia Partner Forum. This group that really focuses, conservation questions across a broad collaboration of agencies and tribes and First Nations, NGOs and universities. We've got to continue to look at wildlife conservation through an organic collaborative lens rather than just based on our political boundaries. And it's so easy as agencies to say, oh, I'm funded to do this right here and you're funded to do that right there. But that's not the reality. We have an ecosystem and we're all part of it. And we have to continue driving management decisions with science, working toward wildlife reintroductions and augmentations, but with a broad array of stakeholders. These are landscape scale actions that requires all to be engaged and to figure it out together. Because humans are part of this ecosystem. We can't forget that. We're part of it one way or another. And I think we've got to keep that in the front focus.
Thank you very much. Mead, I'd love to hear your thoughts on this.
What I would really love to see, so all of these stories, right? All the stories Jen's telling and Jason's telling, I cannot express to you the tenaciousness, the scrappiness, the grit of the folks who've been making this stuff happen, because it's been happening oftentimes without the mandates and fundings and support that were really needed to see what has to happen at the scales that things have to happen at, right? So I-90, the reason that was so successful, they had a mandate. Like the head of Washington DOT was like, we're gonna make this happen. And guess what? It did, because it was like signed, stamped, and delivered, you're gonna get this done. We need similar strong mandates to do this large landscape level work from all of our agencies, all of our land and wildlife management agencies. We need it on both sides of the border. Is not sexy. Like we need, policy. We need like things in writing that we need to have our managers, these folks working on the landscape who are really trying to do the right thing. They need to be empowered to have the authority to actually like take the level of action that needs to get done to get this done, and then the funding to see it done. So I feel like all of this is getting done, like pushing against a dam, and that just needs to burst. And we just need to like empower folks to get the work done that needs to get done, because they are trying so hard. And hopefully, at least at the federal level, some change is coming where we could see some of that work open up. But I'd love to see that happen at every scale.
Hear, hear. Thank you very much for that. I think it's really amazing how much has happened, and it's really amazing how much has happened despite sort of attention to this issue, and how much more needs to happen. So I want to thank each of you very much, and for this wonderful panel, and turn to our attendees and say that I hope you've enjoyed this look at what it takes to build regional climate resilience, from the science to the partnerships to the public and private support, management innovations, all the way to the hard work happening on the ground. I want to thank all of the panelists for their time and expertise, and all of the staff who made this evening run smoothly. Thank you to our dean for kicking us off. Thank you for our partners in building climate resilience. Thank you to all of our supporters for enabling us to not only do this important work, but to share it with you tonight. So tonight we covered just a sliver of the work that's happening across our region to adapt to a changing climate. We barely scratched the surface of what's happening around wildlife conservation and coastal resilience. But there are also good stories to tell about progress building climate resilience for rural communities, for managing flood risk, water quality, addressing climate impacts on wildfire risk. There's a lot of stories about these efforts and more on our website. Please check it out. So I said earlier that the purpose of this evening was to provide hope by letting you in on the happy secret of climate resilience in the Northwest, that there's more and more inspiring work going on to prepare our region for climate change's impending consequences than you could imagine. And I hope you have that hope and that inspiration and are energized the way I am. But there was another purpose too for this evening, and that was actually to galvanize each and every one of you for the hard work that lies ahead. Because as much as we've done, there's still much more to do to prepare our region for the changes we know are coming. We have good examples here of what to do, and we need to do much more of it, many more places, and very rapidly. And to protect our communities and ecosystems, our coasts and wildlife, we urgently need to limit warming by turning the tide on fossil fuel use and eliminating greenhouse gas emissions. So before we sign off for the evening, I want to invite you to our next 2 anniversary lectures, which are coming up in January and March. And you can learn more about these events using the link that shows on the screen or the QR code to access our website, or you can just wait for the follow-up email that we'll send next week with more information about how to register for these events and stay in touch with the Climate Impacts Group. I want to express my sincere thanks to our panelists who are our partners in this effort and for the good work you're doing to make our region have hope in the face of climate change. So thank you everyone again for joining us, and have a wonderful rest of your evening.